We're going to continue our discussion about amino acids. So when multiple amino acids come together, they form a peptide. A peptide can be a di, tri, oligo, or polypeptide, depending on the number of amino acids that form it. If it's just 2 amino acids, it's called a dipeptide. If it's 3, it's called a tripeptide. And if it's more than 3, it's called an oligopeptide. And usually amino acids that come together and have more than 20 of them coming together, it's called a polypeptide. An amino acid by itself is not called a peptide, it's just called an amino acid. So you cannot have something called a monopeptide. Once an amino acid becomes part of a peptide, it is now called a residue. 2 amino acids are linked to each other by a bond called a peptide bond, which is a type of amide linkage. It is a type of covalent bond, and as we'll see in the mechanism, we can also see that there is resonance because there's delocalized pi electrons plus the lone pair of electrons from the amino group that can allow for the bond to be on the carbonyl, carbon, and the amino group next to it. The bond is rigid because it does display a partial double bond character, as we'll get into. The formation of a peptide bond is a condensation or a dehydration reaction. You'll hear it both ways, which basically just means that condensation means that you're having 2 amino acids come together to form one peptide bond, and then dehydration reaction because in this formation you will lose water, and I will explain where you get the water molecule from. Once again, you can hear the reaction being described as a loss of water reaction, or you can also say that water is being produced in this peptide bond formation. Since amino acids have a carboxylic acid group, they do undergo acyl substitution reactions. The mechanism is as follows. You have 2 amino acids, and this is your final product. So, the carbonyl carbon is electrophilic. The amino group of the second amino acid will attack the electrophile because this amino group is nucleophilic, meaning that it loves to make bonds with this carbon over here. Your final product will be a bond right. The black bond indicates where the new peptide bond is being formed. Also, it is important to note that your R groups would be facing the opposite sides once the bond is formed. Like I said, you will lose water in this reaction, or you will be producing water in this reaction, and that is possible because the carboxyl group gives up the OH group at the end, and the amide loses one of its hydrogens. The opposite of this formation is called hydrolysis, and this is usually taken through by special enzymes called proteases, and these proteases are usually activated in very special circumstances. For example, they require the acidity of your stomach to be activated in order for them to go and cleave peptide bonds. Usually they are very specific. Some common examples include chymotrypsin, but it's not necessary for most classes to memorize the exact mechanism that they or the exact amino acids next to which they cleave. The amino side is called the N terminus, and the carboxylic side is called the C terminus. The next amino acid can come in at the C terminus only. So when you're reading this, you're going to read this from the N terminus to the C terminus. Proteases break the peptide bond by doing the opposite of the reaction. So they just add water across this bond to cleave it into its 2 separate amino acids.